TLDW. This, and this makes this. Yep, today we're building a Bluetooth speaker. We'll kick off with the objectives. The first one is to keep it simple, so low cost, a DIY solution, and just don't overcomplicate anything. This needs to be simple so that I can make sure I finish it, even though it might not be a perfect solution. Secondly was more to do with connectivity, so I wanted to have Bluetooth and a hardware volume dial. Thirdly, I needed to be loud enough so I can listen to it in the workshop while I'm working. The last objective was to follow some basic audio principles. I'm by no means an expert, but these are the ones I came up with. Firstly is to make sure that everything is sealed where it should be, and the only openings are those that are designed to be open. The box in which the speaker is going to be placed needs to be the correct size. So for each speaker design, there's a specified calculated design volume which you need to work to. And the last part of this audio principles is to make sure that the overall body is rigid. By the way, I'm absolutely no way an expert in any of this at all. This for me is a DIY, make it up as you go along, do some research along the way to make sure it's sort of correct. But in the end, I just want something that works. If it sounds really great, that's a bonus. If it works really well, that's a bonus. One of the best resources that I found available online for helping me get started with this specific project was a similar video about a DIY concrete Bluetooth speaker by DIY Perks. Now, I'm not going to be doing concrete, obviously this is a 3D printing channel, so my enclosure will be 3D printed. But the electronics inside could potentially be similar, right? So I decided to look at what components he used and try and buy the same thing so I could get some kind of table concept up and running in terms of producing the sound, the Bluetooth connectivity and that sort of thing. So what better time than now to take a look at the components that I bought initially and also how they changed over time to become the final solution. This right here is the USB Bluetooth receiver. There were two main problems with this. Firstly, the audio quality was really not very good at all. I mean, it was maybe passable, but I wanted something a little better, and it also seemed to get excessively hot for no apparent reason. In the end, I settled on an M28 Bluetooth module, which has the same sort of principles as the USB device, but it's set up in such a way that I don't have to remove connectors before adding other ones, and it just seems to work a little bit better. This is the audio amplifier. It works just as expected, apart from one factor. If you use a 24 volt power supply, you also need to pair that with 8 ohm speakers. If you pair it with 4 ohm speakers, it operates at 60 watts, which is too much power, and I think that's how I blew up the first one. So instead, I'm moving to a 12 volt power supply, which reduces the power output to 15 watts. I wasn't sure what potentiometer I was going to need at the beginning, so I got a bunch, but they were all rubbish. So I got another one, and that one was rubbish as well. So I got another one, and that turned out to be just the right one that I needed. This one is a 50 kilo ohm dual linear taper volume control potentiometer switch. It has the switch for the power and 2 channels for changing volume. This is the power supply that I picked up initially, thinking I was going to be working with 24 volts, but I didn't really trust it, mainly on the basis they can't even spell switching correctly. This very basic 12 volt 3 amp unit is the one that I ended up using. This little device is what I purchased to be able to step down the voltage from the 12 volt input to the 5 volts needed for the Bluetooth receiver. Unfortunately, I did have some trouble with it, so I swapped it out for this instead. These are the Dayton Audio ND65 4 ohm type speakers that I ended up settling on. They're pretty small, but hopefully should be suitable for a fair amount of bass as long as I get the enclosure all sealed correctly. Oh, and this is the 5 volt isolator. Understanding all this electronic stuff in my head was just a little bit of a stretch, so I decided to write it down in the form of a diagram so I had something to follow when I was wiring things together, so I didn't have to remember everything all in one go. And it seemed to work out pretty well. Yes, I know it's a bit of a mess. I'll work on that as we get a little bit further. But now that's sorted, I need an enclosure. There are 4 features that I'm trying to keep an eye on as I'm doing this design. That is the rigidity, the internal volume, ensuring that there's some space for the electronics, and also how I'm going to seal it. So the rigidity factor was basically just determined by how thick I could make the walls. As long as they were nice and thick, I knew that the overall resulting thing would be also very rigid. Secondly, the volume I maintained by basically drawing the volume that I needed inside and then doing a kind of reverse shell feature to make that modelled space than the cavity. You'll have seen that right at the very early steps of doing this design. Ensuring that there was space for the electronics was quite easy, although I probably did go a little bit overkill. There's a lot more space than I actually needed. And lastly, the main way I sealed it was with a piece of TPU. So between the main body and the faceplate, there's a thick TPU seal that runs between the cavities, between the inside and outside. It's just one big kind of gasket and a whole load of screws around the top face clamped down through into the main body. To do this, I used brass inserts. We'll have a look at the end when we get into the assembly how well that's actually going to work. The next challenge is to find out how we're going to actually print this thing, because it's getting pretty big. So I didn't want to print the whole speaker in one section. I decided to cut it up. So it's in like 3 or 4 sections. Can't remember how many I did, but that just reduces the overall printing time for each of the sections, and then I can just repeat for the multiple segments. The other thing that I wanted to do was obviously print it fairly quickly. So I used a really large nozzle from the Dies design on the extrudinator. I think I used like a 0.9 millimeter nozzle. So like 0.6 layers and I think like 1.5 millimeter line width. So that makes your construction quite quick to print, and it's also really rigid because of all the thick lines and large line width. But I didn't necessarily want that same aesthetic on the outside. A lot of the time with very large nozzles, you get some artifacts in the retraction and stuff, and it's quite hard to hide those. So what I did for that was move to a kind of outer shell. So it's got like a thin skin that's 1 layer thick, which is basically a big spiral. So it's a large Varsmo print for the very outer shell, which means I can have something that looks kind of pretty on the outside, and then whatever I need on the inside to make it work. In order to assemble them, there's these pinholes in between the layers, which allow for alignment, so they push together, and then I just fill the whole area with glue as I assemble it in order to make sure that it's properly sealed. Again, one of the main objectives. Now, I think just one thing left to do. So although this was not much of a how-to guide of exactly how to do this, I will be leaving links, bill of materials and printed parts and stuff up on prusaprinters.org if you do want to take a look. It is quite I'd say it's not too difficult, not too complex a project. As long as you can get the wiring right. I'll try to put a decent diagram online so you can wire it up correctly. Other than that, I'm really honestly super happy with the project. You should have seen the moment that I got it all working and plugged in for the first time. I was kind of dancing around the room. I was so happy with it. It was good fun. With that, thank you very much for watching, and I will see you in the next one.